Hey physics students, this is Mr. Resentis again in chapter 2, page 48. I'm going to go through three different equations. Average acceleration on page 48, and then I'm going to go through the equation for displacement with constant acceleration on page 52, and then I'm going to go through the velocity with constant acceleration and displacement with constant acceleration, and I probably will run out of time by then, so we better get started. The first is chapter 2, motion, one dimension. All right. Average acceleration is change in velocity in a given time. So, acceleration is change in velocity over time. V final minus velocity final minus velocity initial over time final minus time initial. And so we could use the exact same triangle that we used before: velocity, acceleration, time. We could solve for any of these if we need to. If we need time, divide velocity by acceleration, and if we need velocity, multiply acceleration by time. Here's an example. A car traveling at 7.0 meters per second excels at 2.5 meters per second to reach 12 meters per second. How long does it take? This is actually practice B on page 49, and so I don't think you need to copy it down, but basically what we're going to do is 12 meters per second. That's our velocity. That's our velocity final. Minus 7, which is velocity, velocity initial, divided by 2.5 meters per second squared, and that's our acceleration. That's our average acceleration, and so that equals 2 seconds. All right. And so in this case we wanted time, so velocity divided by acceleration. So that was simple enough. The next example is displacement. Remember, there's a big difference between displacement and distance. We're not going to be able to use delta x's. X equals xf minus xi because we have acceleration, we have velocity. We don't have the x's in this case, so we have displacement. And I think I'm on the practice problems on page 53. Here's an here's the equation. Delta x, that would be displacement, equals 1/2 velocity initial plus velocity final times delta t. So this looks like base times height, 1/2 base times height. This looks like we're trying to find the area of a triangle here, and I believe that's exactly what we're trying to do. Here's our displacement, and here is velocity final. Here is time final. We're just trying to find we're trying to find the area of a triangle here, so this should be fairly easy. a car accelerates from rest to a speed of 6.6 meters per second. Car accelerates from rest, so that's why we started at 0 over here, because it's from rest. That would be 0. And it accelerates in 6.5 seconds. Find the distance the car traveled during this time. All right? Simple enough. We're going to use this equation, and delta x equals 1/2 6.6 meters per second times 6.5 seconds because it started at rest. That's why you don't need the initial. You don't need the initial. That's unnecessary because it's 0. All right, so 0 plus 6.6 would be unnecessary for me to write that. Equals 21 meters. All right. All right, so let's see if we could fit one more in. Velocity, final, constant acceleration. So we're looking for velocity final with constant acceleration. So v final equals, all we're doing is rearranging equations to get these. Here's our equation. All we did was rearrange it so that we can find the final velocity. A car's speed is 6.5 meters per second. Accelerates to 0.92 meters per second squared. Well, we know that's acceleration because it's second squared. For 3.6 seconds. Find two things. Find the final speed, and I'll just mark that as A, and we need to find the displacement. And this is practice problem. This is practice problem on page 55. So you don't need to copy it down if you don't want to. Okay, so A, which is final speed, is 6.5 meters per second plus 0.92 meters per second squared times 3.6 seconds equals 9.8 meters per second. All the information was given. All the information was given in the question. All I did was I just plugged it in. The only problem that you're going to have is you're going to remember your algebra. You've got to multiply first before you add. If you tried to work this from right to left, you wouldn't be able to work it out because you have to do the addition last, and you remember that from algebra. All right. So B, displacement. You remember the displacement equation? We just did it. I, that's t plus 1/2 acceleration. No, we rearranged this equation actually. So displacement, and then now all we're going to do is we're just going to fill in the numbers that are given. So it'd be 6.5 meters per second times 3.6 seconds plus 1/2 0.92 meters per second squared times 3.6 squared, and that's the change in time squared. Here's the this is the acceleration, and this is the time, the change in time, and then here's the initial velocity. So if you plug all that in, delta x is 29 meters.